All right, good evening, everybody. Let's make sure my microphone. Is my microphone not working again? Let's see here. Oh, no, it looks like it is working. Okay, good. I looked at the wrong one. Hey, everyone. Happy Tuesday. Hope everyone's doing all right tonight. We are covering Encore section 1.3 tonight really, it's all about cloud and on-prem deployments. So for anybody who's really just kind of, I don't know, most everybody at this point has probably heard of the cloud, whatever that is. And Cisco does expect us to know a little bit about what this cloud is if we're going to go take the Encore exam. So we're going to dive into that. First off, let's pull up our agenda and see what we're up to tonight. So really what we're up to is we're going to start off by describing what exactly we're deploying into the cloud and how that looks like if we don't deploy it into the cloud. And then we'll talk about different cloud models. So the services models, whether it's an IaaS deployment or a software as a service deployment. And then we're going to go into the different deployment methodologies, for example, public cloud versus private cloud versus hybrid cloud. So we've got a lot of different cloud technologies that we need to understand if we're going to go take the Cisco CCNP Encore exam. So, with that said, I do need to make a couple of quick announcements. First of all, for those who missed it today, Cisco did announce something pretty big, which is, I guess, two things. First of all active certifications, every single active certification out there has been extended by 6 months, the deadline recertification date. So if you had a certification that was going to be expired in, I don't know, next month, April, let's say, you've been given 6 more months because I don't know if anybody's noticed, but right now it's pretty hard to go take an exam. Everything is shut down. And so Cisco wants to make sure that we're capable of, at this point, we don't know when everything's going to be open back up, but they want to make sure that everybody has enough time in order to recert their exam. So that affects me personally. All of my certs were up for refresh in October. So that gives me an extra 6 months. So now I'm more than a year out. So that's always nice to have a little bit of extra breathing room on your certifications. Chime into the chat if you have any questions about that. The second part of that announcement, which is sort of interesting, it's not really an announcement at this point, but they did say in that release that they're working diligently on online testing methodologies. So there's obviously, I can't even imagine all that's going to have to go into the idea of taking online tests because, if I'm taking my online test on this screen, I could have my CCNP book up on that screen, or I could at least have Google, if nothing else, to Google Answers. And so they're going to have to completely rethink this. Now, fortunately, they don't have to invent this wheel. Online tests have been in development for a long time. So it's just about embracing the right technology, embracing the right partners, and making sure that they go about doing it the right way. But I do expect probably in the next couple of months that we're going to hear some kind of announcement from Cisco as far as taking online tests. And I don't have an inside track. I'm not saying that because, my brother works at Cisco or whatever. I don't have any connections. I just know that Cisco's looking at that as, number one, lost revenue. People paying, I don't even know how many dollars they're pulling in a day on people taking exams, and they're missing that right now. But, maybe a little more altruistically, they want to make sure that everyone's able to go after their certifications. Because right now, if nobody's able to go get certs, leaves a lot of people in the lurch, especially people who are in the middle of studying. I know my brother-in-law is in the middle of studying for his CCIE right now, and a lot of his plans are in limbo, unfortunately, because of this whole virus deal. So that's announcement number one. The second announcement that I need to make is this will be my last stream on Twitch. So I am embracing the CBT Nuggets. All of our trainers are really focusing on YouTube Live. And the general marketing push from CBT has been to get onto YouTube Live. So this will be my last week on Twitch. The schedule, if you look below me here on my channel, you'll see that the schedule is only updated until tonight. And so we are going to, go through this and tackle cloud versus on-prem. And then hopefully within the next few weeks, I'll figure out what exactly YouTube Live is going to look like. And my goal is by the first week of May to be back online with these regular streams and we'll just kind of keep picking it up where we left off. So the plan is to focus on Encore. I know a lot of you out there have already passed your CCNAs. You're ready for that next level. And so we're going to definitely tackle that on this channel. It just won't be Twitch anymore. It'll be YouTube Live. Okay. So announcements are out of the way. It wasn't even on the agenda, but I needed to make sure that was said. So let's just go ahead and dive into, yep, there we go. Let's go ahead and dive into our conversation on cloud. So first and foremost, let me pull this up. What in the world are we storing in the cloud? What are we worried, like, what is this concept of cloud versus on-prem even really driving at? Well, the first thing that we're driving at is the fact that we need to be storing our applications and our data somewhere. So in today's modern network, we typically have something called a data center. A lot of us have heard of this, potentially, if nothing else, because Cisco makes data center products. For example, here I'll write Cisco. So Cisco has their Nexus line of switches. Cisco has their UCS line of servers. They have HyperFlex for storage. They've got a lot of data center specific hardware and software. This is just hardware. Their software package, I mean, they've got 5 to 10 different software packages I won't even go into. And then if you've ever heard of their MDS line of switches, these are fiber channel switches. So Cisco is very invested in the data center. So the question is, do we even know what the data center is? Because I know when I was studying for the CCNP, I didn't really have a grasp of what that data center was. I was so focused on networking. It's like, just make all of the bits and bytes move in the network, and I don't even know what's in the data center. I just know it's really important. If you're in that boat, don't worry. We're going to go into a little bit of details here. Really what it comes down to is our organizations have two very precious resources. We have applications and we have data. This is the core of what we're storing in the data center. It's why we call it a data center, is because our data is storing there. When we think about it, we in IT are sometimes, not always, but sometimes we are segmented a little bit too much from the actual business. So the business is looking at it from, I'll use an example. I used to work for a medical clinic, and all of IT was in a separate building from the actual clinic. And so when I showed up to work every day, it was just me and a bunch of IT folks, whether they were developers or server people or my fellow network guys. I mean, it was just, we were all showing up to the technology building, and that was all we knew. Well, that's great, except every now and again, I would actually have to pack my bag and go over to the medical clinic. And usually I'd have to throw some khakis on too, because we could wear jeans, but we were not to go to the clinic with jeans. Didn't look professional enough. So I had to throw my slacks on or whatever, walk down the street and into the medical clinic. And it struck me multiple times that, wow, you know what? I forget this, but we are in patients, right? I mean, like, we're a medical clinic. We're seeing patients. People are coming to see a doctor and to get prescriptions and to, have their vitals checked. And my day to day was sitting in a small office, basically a cubicle, working on network gear. And so there can be this chasm between the business over here on one side of the chasm and IT here on the other side. And we forget that this is why our company exists. We are here for a reason, and the reason is, in my case, to see patients. Or, hey, maybe you work for a retail store. It's to service goods. Maybe you work for a bank, right? I mean, you're a financial institution. You're there for your customers and for the people who are trusting you with their money. And so if the business isn't able to do business, then they're going to go out of business. No other way to say that. And so in IT, we are facing a time when we need to be more savvy at the business side of the house than we've had to be in the past. We have to understand business concepts. If we don't understand business concepts, then all we are the proverbial IT nerd in the corner, maybe with the lights out, just punching away. And we're really just an obstacle to doing business. A lot of businesses see their IT shop as an obstacle. They see it as a cost center, a drain on their bottom line. And we're not doing ourselves any favors if we contribute to that mindset. So the more that we can understand the business side of the house, the better it is, first of all, for us career-wise, because we're going to be seen as more valuable that way. But second of all, IT now can actually service business needs rather than simply, I don't know, just kind of checking boxes. Oh, yeah, the network's up. Yeah, this is that. Because otherwise, we in IT, if we start making decisions based on technology alone, a lot of conversations are going to be, hey, IT, we need you to do this. And we're going to say, no, we're not going to do that. It's not secure, or it's inconvenient. There's no good way to do it, or it's just, it's going to cost too much money. That's a common one, right? And we become the department of no. No, we're not going to do this. No, we're not going to do that. No, no, no. And then, you think about it from your perspective. If you were showing up every day at your job and somebody was preventing you from effectively doing your job, you're going to get really sick and tired of that really fast. And so, no different. If IT is always telling the business side of the house, no, we're not going to do that, we're eventually going to be deemed irrelevant, or at least not worth the time. And people will find ways around IT in order to do what they want to do. In fact, the cloud is one of those ways, because coming back to this concept here, let me get a new color here. Coming back to this concept, the business cares a lot about applications. Okay, applications are, I don't know, you hold up your smartphone and you think apps. Apps are not like to us. Apps are for fun, for the social media, email, Twitter. Well, that's social media, I guess. Maybe some games and things like that. But to a business, the applications are what keep the business running. So we might have a payroll app. We might have a resources, ERP system, CRM tools, so like the salespeople can track their sales opportunities. It's all of these applications. Some of them allow customers to place orders. If you're an order-taking company and your application for taking orders goes down, then you can't do business anymore. So that's why we care about applications, and those need to stay online. This is why it's so important that the network stays up. It's not like somehow the network magically makes our business happen. The network provides access to these applications, one of which is the internet, of course, and a lot of applications do live out on the internet. So there's that as well. But then there's data, of course. For some companies, this is a big deal. For some companies, it's not. It's going to depend on how important it is to these organizations, like to your particular organization, the data that you're storing. So like customer information, for example, that can be very important. If you are an engineering firm, how you make things, your patent information, that's very confidential data, and that's very important. If you have customer data, like personal data, you're a hospital and you have everybody's social security numbers and such, that's very sensitive data that you're storing, and you need to keep it safe from the bad guys who are trying to steal it from you. We hear about the data breaches when they happen. So applications and data are why I keep coming back to this concept that it's the lifeblood of an organization. And if we don't have apps and data, we don't have potentially our business. So that's where we need to zero in a little bit on what we're trying to accomplish with the cloud. Okay. So within the data center, we're going to take some servers, maybe some UCS servers, and this is called a virtual host. And on this virtual host, we're going to host something called virtual machines. Now, this virtual machine, I'm going to draw it a little bit different here. This virtual machine tends to be an instance of an operating system and an application. Now, I just threw a lot at you, so let me kind of explain that for a second. When you and I boot up a laptop, whether it's our personal laptop or work laptop, usually it's running Windows or Mac OS or Linux or something like that. Most of the world, it's a lot of Windows. And that is an instance of an operating system. Now, I love to have 15 different applications running at once, right? I mean, even right now, I've got my streaming application going. I've got my notes application. I've got my whiteboard application. I've got a command prompt up. That's not much of an application, I guess. I've got my work messaging app running. If we run a lot of different apps at the same time on one machine. Windows and all operating systems are designed to do that. It's one of the reasons why we have operating systems. But in the business world, when I write a business piece of software that's an application, let's rewind like maybe 15, 20 years ago. And let's say you're a tech support person for this software company. And so somebody calls in and says, hey, your application isn't working, or it's going really slow. And you start unpacking this and you find out that they've got this server, this computer, running an instance of Windows, and they've installed your application, but they've also installed 5 other applications. Well, you're going to get really sick and tired of that. You really, right away, you're going to say, you know what? Tell you what, I don't know what any of those other applications are doing. They might be consuming ports, network ports that my application is trying to consume. They might be consuming all your memory or your hard drive space, whatever the problem is. I'm not going to trust those applications. I'm not going to guarantee that application will work. What you need to do is get that application put onto a dedicated operating system. And that was great, except back in those days, this operating system was a one-to-one mapping with hardware. So I had one piece of hardware, one server, one operating system, and one application. And the hardest part about this is this application might be something that only consumes about 15% of my total resources on that computer. So we're all going to look at that and say, okay, well, let's install 5 other applications. But no. The application vendors won't support that. So we have to have our computer sitting there at 15% utilization. And by the way, because I have 50 apps in my environment, I'm going to have 50 different servers, physical PC, computers essentially running in my data center, running those 50 different applications. Well, this is where virtual machines really saved the day, because the virtual machine allowed us to stretch this hardware out and have multiple instances of operating systems and applications. This way, we can still abide by the application requirements to say it's a one-to-one relationship. However, we no longer have to worry about this 15% utilization anymore. That goes away, because now I stack as many virtual machines on this piece of hardware as I can, and I max out its resources to give me the best utilization. So that's the concept of really what we're trying to do inside the data center. We're trying to put virtual machines, these virtual servers essentially, we're going to keep them online and active and accessible as much as possible and deliver that to the business side of the house. Now, there are some challenges with that, but we'll get into those in a little bit. So that really brings us, this is an on-premise data center. When we talk about on-prem, we're really focusing on my own hardware. So I'm an organization, maybe it's your organization. I have a data center. I have racks, I have servers. It might be 3 servers. I mean, I've seen data centers as small as 3 servers. You might have 3 servers. It might be as large as 200 servers. However many servers you have, that's typically where the data center lives. And we can have, again, we mentioned it, we have networking, we have servers, we have storage networking. We've got all kinds of different hardware components, and I mentioned again, that doesn't even include the software components. We've got hardware and software components running this data center, and it's complicated. Who's running this? I mean, how many people do we have managing it? And what happens if the network has a problem? Now that's having some issues, so that affects the servers and the storage, or maybe the storage is running low, and so that affects our applications. And there's just a ton of different systems that we're trying to bring together in order to make our data center work. And it's complicated, it's difficult. There's a lot of blame that can happen if something goes wrong. Is the network team, is the server team, is the storage team, or maybe that team is all you. Maybe you're one person, you're expected to be able to do all of these technologies, and you get stressed out and you quit, and then the business is like, well, we got to hire another data center engineer. And so there's a lot of problems associated with the data center, and this is where the concept of the cloud comes into play. So let me pull up a new whiteboard for that. All right, checking my notes here. All right, so the cloud. The cloud, a wise person once said, the cloud, I love this, there's no such thing as the cloud, it's just somebody else's computer. Okay? I don't know who said it first. I've heard it from many sources, so it's possible we all just started saying it at once. But either way, there is no such thing as the cloud. It really is just somebody else's data center. When we talk about cloud vendors like Amazon and Microsoft, those are two of the largest ones, they just have their own data centers with tons and tons of all the equipment we just said. Eventually, all this virtual stuff has to run on physical hardware, actual equipment. And our cloud, again, Amazon, Azure, whatever we're talking about, is just another data center. And we're going to borrow their data center to run our workloads. The difference is I don't have to worry about that physical world. So my virtual machines are going to run on, let's call it Amazon. Amazon Web Services is a very popular cloud platform. And so they've got, I'll draw it like a cloud, they've got their cloud here, and they've got their servers and their networking and their storage and their virtualization and their backups and their DR and all of this is running just fine in Amazon, and they've got all of the support staff in order to make this work. Meanwhile, my organization, I've not got nearly as many people to really make this work. And so I could run all of my own servers and network and storage and virtualization, or I can just spin up virtual machines, these virtual servers on Amazon's, again, their computers, right? For lack of a better word. It's not a cloud, it's somebody else's computer. So that's the idea of a cloud. Now, they're very important if we're going to be going after the Encore exam. Let me find yellow color, sure. There is an American institution called the National Institute of Standards and Technology, NIST, N-I-S-T. We'll write this out. If we're going to go take Cisco's exam, we'd probably better know how NIST defines the cloud. As much as anything, it's because the world is kind of centered around their definition, which comes down to 5 different characteristics. So the definition of a cloud computing service will have these 5 characteristics in some form. The first one is, we'll just say 1. Number 1, on-demand self-service. On-demand self-service comes down to this. How do you spin up a new virtual machine? If you're ready to deploy a new virtual machine, how do you do it? If the answer is, well, I pick up the phone and I call Amazon and I say I need a new virtual machine, that's not a great answer. That's not very on demand, especially if Amazon is only open 8 to 5. Naturally, Amazon's not going to have that, but what about a local regional cloud provider? I was talking to an organization once. We were talking about their cloud vendor, and they said, well, it's all right, but we have to call in to spin up new virtual machines, and they're not open on weekends, and it's very painful for us to do that. And I thought, wow, wait a second. How do you define yourself as a cloud organization if you don't have on-demand self-service? So the concept of self-service simply means I can do it myself. I can service for myself. I can spin up my own virtual machines. Usually this is going to come in the form of a web application. I'll point my web browser to, Amazon. Again, I'll keep using Amazon as an example. Azure and Google and IBM and all kinds of other vendors have very similar interfaces. I'm going to point my web browser out and I'm going to spin up my own virtual machine. I shouldn't have to call Amazon. And I shouldn't have to worry about whether Amazon is open in the middle of the night or, again, my local cloud provider. This should be on demand, meaning all the time, whenever I want. On demand self-service, meaning whenever. So whenever I want, I can do it myself. It's not to say that if I need support, that's a different situation. But as far as just my day-to-day, what I'm doing, that should be on demand. And it should be serviceable myself. This is one reason why what we have happened sometimes is we have the business side trying to decide between IT and the cloud. They say, well, we're all in IT, so we think IT is the good guys, and so they should pick us to deploy their applications into our data center rather than going out to the cloud, which does usually cost more money. Cloud is not cheap. Cloud is usually the more expensive solution between running it myself and running it in the cloud. And yet, over and over and time again, the business side of the house is sending a lot of these applications up to the cloud and saying, we'll just run it in the cloud. Well, why are they running it in the cloud when it costs more money? Well, it's because money isn't their biggest care about. In IT, we tend to be, we're servants to the almighty, dollar or euro, whatever form of currency you use. Like we have to fit it in our budget. Yet the business people are like, you know what, it doesn't really fit in the budget, but it's going to make us be able to do our jobs better, so we're going to go do this. And so if, again, on-demand self-service boils down to a question. If you have a developer in your organization that needs a new virtual machine because they're going to deploy an application to it, maybe it's to run a quick test on something or what have you, how do they get new virtual machines? Are they picking up the phone and calling you? And, hopefully you go home at night and you get to see your family or what have you. So if they need a virtual machine at 1 a.m, are they able to spin it up? Is it on demand? Is it self-service? Can they do it themselves? So this is one of the reasons why they're going to the cloud. Now we're going to find out later that we can still deliver on-demand self-service in our own data centers. That's called a private cloud, but it takes intentionality and it takes some investment in resources in order to do that. And so a lot of organizations that I've worked with, they don't have a true they don't have a true private cloud, because even though they have an on-prem data center, they're not providing, for example, on-demand self-service. Let's look at the second definition, or characteristic. Sorry, these are characteristics. Broad network access. Broad network access essentially boils down to how do you get to it? Now, the easiest way, if I'm going to say it's broad network access, that means it should be accessible from basically anywhere. Broad network access, if it's available on the internet, that's pretty much these days, the definition of broad network access. If I have to VPN into another network somewhere, that's not very broad. And if I have to be in some part of the world, maybe I have to be in Europe to use this service versus, I'm going to have my organization in Australia try to dial into this, but it's IP blocked or whatever. That's problematic. It should be accessible as much as possible, wherever possible, whenever possible. Okay, so for the most part, this one's pretty straightforward. There's not a whole lot to drill into on this one, but it should be accessible very easily. And I think the best way to relate to that is, with my private data center, a lot of times I do have, if I'm sitting here at home and I need to check on the servers, usually I have to VPN in. And what if the VPN service is down? That could be a problem. There's a lot of chicken and egg issues where your data center, something reloads in the data center and the authentication server is not coming back up. And because the authentication server is not there, I can't VPN in, which means I have to drive into the office, which maybe is a half an hour away. And so now it's just going to delay and delay and delay. Those problems shouldn't exist with a cloud deployment. All right, third. Again, we don't need to spend much time on that. Resource pooling. Resource pooling is a fancy way of saying that I'm going to take a bunch of resources, pool them together, and allow them to be consumed by many different individuals. So this equates to a concept we call multi-tenancy. So Amazon is probably not building an entire data center for one customer. They're probably not even deploying a single server for one customer. The idea here is that they will deploy a single server, and it's going to have some amount of CPU, some amount of memory, some amount of storage, and this will be pooled together. We'll call it a resource pool. And then all the different customers, maybe customer A, customer B, customer C, are all going to use this pool of resources. Okay, it's very efficient. Remember, we talked about with the virtualization concept, I don't want a server sitting there at 15% utilization. I want it as close to 100% because I spent all my money on that. I didn't just buy 15% of it. I bought 100% of that server. I'm only using 15%. So same thing with a managed or a cloud provider, Amazon or otherwise. The more hardware that's just sitting there bored, the less money I'm making, or at least the more money I wasted. And that's not good. So we want to pool our resources together. It shouldn't be, it comes back a little bit to self-service, but I shouldn't have to go out and provision new servers because you want to spin up a virtual machine. I should have a pool of resources ready and available for you and for every other customer that wants to dial into my cloud service. All right, number 4, rapid elasticity. So this is a fun one. And I'm going to use Netflix as the example. I love to use Netflix as the example for this. So, hey, Ben Halverson, thanks for saying hi. Thanks for hanging out. Talking about cloud tonight. So, oops, I didn't finish that. Elasticity. Rapid elasticity. So Netflix, if you think about it, let's say there's, normal amount of traffic. Netflix, people are streaming Netflix. Sorry, I'm late. One of the other streamers I follow just got a new puppy. Well, welcome, Big Papa. And it's hard to compete with new puppies. So no worries. I don't fault you at all for that one. Boy, that's a good gig. I'll have to come up with something in competition with that. I don't know. Hey, while I've got you and Ben here, I just want to make sure I made an announcement earlier in the evening. This will be my last live stream on Twitch. I will be moving over to YouTube Live after this. So all the CBT Nuggets people they're being encouraged to move over to YouTube Live. And there's also some advantages behind that from call it cataloging perspective. As people are looking for things, it's easier to find that on YouTube than on Twitch. And so we're just going to try moving platforms, and it'll probably take a few weeks to figure that out. So expect at least by the beginning of May, if not the end of April, that I will be back and on YouTube Live. So just want to make sure that message got across to everybody. I'll make sure to announce it again at the end in case we get other people to join us. All right, so we're on the 5 characteristics of cloud computing per the National Institute of Science. No, I always do that. Standards and Technology, not Science and Technology. Number 4, rapid elasticity. So the idea here is this. Yeah, I know Twitch is a better platform for streaming. It's really, again, it comes back to that cataloging concept. So I hear you, though, on it. People just aren't searching for networking stuff on Twitch is what marketing is finding versus people are searching for stuff on YouTube. Anyways, it is what it is. I don't necessarily disagree with it, but at the same time, it's kind of sad to move platforms. So hopefully you're able to still join us on YouTube. I don't want to lose I don't want to lose anybody in the transition, that's for sure. Restream. Yes, that is a good point. We could do Restream, and I've thought about that, and we're considering that. But thank you very much for the suggestion, because that is a good point. All right, sorry. Well, back to rapid elasticity. Let's knock this out. So the idea of rapid elasticity is saying that I was in the middle of an example. Let's just cut right to the chase. The idea of rapid elasticity is saying that I have an application that all of a sudden is getting hammered. It needs more resources. And if I'm a cloud service provider, I should be able to allow that application to spin up more resources as long as it's available in the pool and as long as they want to pay for it. But they should be able to spin up all those resources and then spin them back down as when they don't need it. So I was using Netflix as the example because Netflix actually does famously run on Amazon Web Services. They run their entire infrastructure in AWS. And one of the big reasons for that is because they want to use and pay for what they need at any given time. So 4 o'clock rolls around and everybody comes home from school and they're all hitting their regional virtual machines, these Netflix servers that are serving up data. They want to be able to ramp the production of that up to meet that need and then cool it down when everybody goes to bed. Or for example, if a global pandemic happened and everybody in the world started streaming Netflix all at once, Netflix needs to be able to spin up as many resources as possible. And so they have invested fully into Amazon's cloud primarily for that functionality. But I on a more personal note, I have worked with a company in my area that they're a party store. They do prom dresses. Prom is like their biggest season of the year. And they sell a ton of stuff around prom season. And so their utilization of their network looks, if I draw it like this, it does this. So it spikes up during prom season and it does that the rest of the year. So in a private data center, if you're just running your own data center, how many resources do you need running at any given time? Well, you need that many resources running, even though for the most part, for most of the year, you're not even going to be using those resources. But if it comes around to prom season and you're measured out down here and you can't support all of the load that is needed in prom season, then you're going to be in trouble. And IT folks are going to be out of a job because, again, the business side matters. And if they can't make sales, they can't make payroll and they can't afford to pay you. So we need them to make their sales. And so we're going to spend more money than we want to make sure that we can support that influx. Well, if that one application was put into the cloud and the cloud can run it really low for most of the year and then it can spike up for prom season, then go right back down for the rest of the year, then I can size my on-premise data center right here. I can make sure that I don't invest too much money in my hardware that's just going to be sitting there idle. Again, we do not want hardware to be sitting there idle. All right, Big Papa, I do the same thing with my server. Shut down one Minecraft server was not being used. Spin up my EVE-NG VM for labs. Goku, thanks for following. All right. Yeah, well, I don't know. I mean, Minecraft servers are very important, I suppose, but so is studying for certifications. And by the way, Big Pop, if you didn't see the announcements today, that Cisco has pushed every active certifications, what's the word? Not retirement. The recertification, the deadline for recerting. It's going to. They gave us all 6 extra months. I'm not sure why I can't explain that in some few words, but so if you had anything that was needing to be recerted by, let's say, June, you have until December now, and we'll see if they don't even push that back a little bit more. They are also working. They announced this. I don't have an inside scoop, but they did announce also that they are looking very seriously into online testing options as well. So, don't private data centers run bare metal servers for the most part? No, I would argue not. But when we talk about bare metal servers, we're truly talking about, or usually, I mean, maybe it's different in different parts of the world, but for me, a bare metal server is not running a hypervisor. So I know you missed the start of this conversation. We mapped out, actually, through the magic of software, I can go back in time. But we talked about this concept of applications and data. And so we've got the virtual machines. Whoops. Yeah, I didn't pick the layer. Anyways, we've got these virtual machines that are running on the host because every application requires a one-to-one mapping with an operating system. And so a bare metal to me looks like this. It looks like application on an operating system on a dedicated piece of hardware. So usually you're running like Windows or Linux here versus a host, a virtual host is going to have one piece of hardware that runs many instances of virtual machines, which would be essentially maps out to an application to operating system instance. So that's where to me it's bare metal, but most data centers should be running on that more so than bare metal because bare metal doesn't scale particularly well. But there are some applications that require it. They'll say they won't support being virtualized or what have you. So you always got to pay attention to that. COVID-19 is interfering with testing centers. I'm glad you saw that was the 6-month extension. To me, bare metal's like ESXi running on a machine hosting several VMs. That's interesting. When I was doing data center consulting, whenever we talked about bare metal, it was, every now and again somebody might have referred to it as just the piece of hardware, but a virtual host versus bare metal applications to me is an application that's just running on a non-virtualized host. So, but, that's just terminology. We all have different ways of saying things. All right. Number 5. So the last one is measured service, which I like to call it metered service a lot, but it's the same thing. Measured service is the idea that I can measure what you're using. So this is turning cloud computing into a utility where, I've got my meter in the back of my house that somebody shows up and they look to see how much electricity I've used every month. The gas company is tracking how much gas I use. The water company is tracking how much water I use. So we've got all these utilities where they are measuring how much I'm using and they're charging me for my actual utilization. Well, that's exactly what should be, according to NIST, should be part of a cloud deployment, is to pay for what you're using. So it's this concept, it ties back to the rapid elasticity. We mentioned it several times. I want to be paying for what I'm using and not paying for what I'm not using. And so measured service basically says that my cloud company will be able to tell how much cloud spend that I've spent, how many cloud resources I've consumed in a month or whatever my billing cycle is, and then they will bill me for what I've used. So that's it. These 5 characteristics. Again, I would expect that if you're going to take the Encore exam, that Cisco would be asking about these 5 characteristics. I would expect that. So we're going to make sure that we have that. All right. Moving on. Onward and upward. All right. So we want to move on to talk. So we've talked about what the public cloud is from NIST perspective. Let's talk about what we call cloud service models. Okay, cloud service models, this will be familiar to probably most of you, potentially. Cloud service, not services, cloud service models. Okay, this boils down to 3 different options. We have infrastructure as a service. We have platform, you shouldn't spell it out, platform as a service. You know what? I don't like the capital A's. I do that sometimes, but I like the lowercase a's. Infrastructure as a service, platform as a service, and software as a service. So these 3 cloud service models are the different types of public clouds that exist. And usually, like Amazon, for example, they're going to have, infrastructure and platform as a service. You're going to find that some cloud vendors have multiples of these, but these 2 are pretty well tied together, as we'll see here in a moment. Software as a service is kind of its own thing. And so let's just kind of walk through this. They are all related to each other, though, which is why they're all part of the service models. What this boils down to is this question: how much do you want to manage? Because we already mentioned this. A virtual machine consists of an application and an operating system. And I might not want to manage that operating system. In fact, a lot of applications will have a series of virtual machines. A pretty common deployment stack would be saying that I've got let's call this a database on the back end, an application server here in the middle that ties back to the database, but then also serves up all of its information to a web server. And this is how, I know this is getting a little busy, but our users are logging into this web server. So any application that has a web front end, I'm pointing my web browser to my application, logging into it. It usually is tied back to an application server, which is accessing the database, right? So I've got 3 different virtual machines. All of them have operating systems. How much of this do I want to support? That's the question. So infrastructure as a service says, I'm going to manage all of it. Okay. Now let's just, one point I should have made. In all of these cases, this is a public cloud environment, so I'm not managing any of the hardware regardless. Okay? If I want to manage the hardware, I'm not in the public cloud, I'm managing it myself. So I guess the common denominator here for all of these services is that we are not managing hardware, we're only managing software in some fashion, virtual machines, applications, etc. Infrastructure as a service says I can manage the entire stack. So I can manage the operating system, I can manage the databasing, I can manage the application server, right? I mean, I'm doing it all. I spin up my own virtual machines. By the way, when we're talking about managing operating systems, we have to patch those operating systems, we have to secure them, we have to keep them all in the same version. And so there's a lot to it. But hey, you know what? It usually is less money. Our dollar spend is going to go up as we go up the stack. And so if I've got the expertise to manage my own operating systems, then might as well do it. Platform as a service is interesting because it's harder to describe. What platform as a service essentially says is I'm going to take some of these services that we've drawn out here, such as a database server. That's a very common example. A development environment is another one where you might have a separate server running a development, like an IDE or some kind of development infrastructure where you don't necessarily want to run the operating systems for those. And so really what you're doing is you're spinning up a database as a service. So I'm I don't have to manage SQL anymore. I don't have to manage some of these things. So it's not middleware. It's just the peripheral services that I need in order to support my application. So if I'm running platform as a service, essentially what I'm saying is I'm going to keep my applications. I'm gonna run. I mean, honestly, the web server could be a platform that I spin up. I just spin up an Apache instance or something like that. That is my web server. And so now I'm running web server as a service. I'm running my database as a service. But hey, you know what? I'm still going to have to spin up some virtual machines and manage those operating systems. But I have to manage a lot less operating systems in this situation. And even then, trying to draw the line here, right? Like, I don't have to service the database itself, but I still have access to the database. Okay. Yeah, if that makes sense. So there's still some servicing I have to do with it. I shouldn't say it like that, but hopefully we're getting the gist of it. I'll come back to platform as a service in a moment because it is a little bit tricky to define. Software as a service is saying, you know what? I'm just gonna make this easy. I don't want any of that stuff. You know what I want? I want access to, really, I'll do it like this. No. You know what I really want is access to this right here. I want access to the application, and that is all I care about. We use a ton of software as a service applications these days. I mean, the trending in the industry is to push everything out to software as a service as much as possible. Yes, it does tend to be the more expensive way to go because you're paying them to run all of this in their data centers, and they've got to pay for their data centers some way. And so life is good, I suppose, for them. But for us, as long as we can afford it, it's the simplest, easiest way to go. So for example, my wife and I use a budgeting application that is entirely software as a service. You know, it used to be that you'd go out and you'd buy a CD or something and throw it into your computer and install the budgeting application, and you'd pull it up, and you'd have what they call the thick client, right? You double click on the icon, it loads an application, you do everything in the application, you close it out, it's all stored locally. But now I just point my computer up to the SaaS provider, which is really just a www address in the internet somewhere. And so I'm landing on their servers. I'm doing all of my budgeting. You know, another one is taxes, right? I mean, tax software used to be something you'd install. Now you just point your web browser out to it. And so, the software as a service is very convenient. They store all of the data, but at the same time, there could be some security concerns. I mean, some company out there knows a whole lot of personal information about me because I'm storing my data on their servers. So I have to have a trust relationship with this company. They have to be online regularly. I mean, if they're constantly down, I'm going to be less interested in using their software as a service. I'd rather install it myself on my computer, and that way it's always available. And this applies to business level applications as well. A lot of payroll applications these days, and ERP systems, CRM, Salesforce.com is a huge example of this, where you used to have to install these systems in your own data center. And now you can just say, I don't even want to spin them up in Amazon. I'm just going to go right to Salesforce.com and I'm going to use their software that way. They pop a cost offset by not needing someone on staff to the operating system support VM provisioning. Absolutely. So generally speaking, you call it cost offset. It's not usually as straightforward as saying that a software as a service, for example, is more expensive but worth it. In a lot of cases, this is where I kind of drew this arrow here, because I can usually decide whether I want to do IaaS or PaaS, but in a lot of cases, not every case, but in a lot of cases, it's either SaaS or nothing. A lot of companies are putting all of their applications into a SaaS environment and saying, we're no longer supporting you deploying our software, you have to come into our data center. It makes them more money. It also is easier for them to support. In some cases, they don't even charge anymore. And that's not always the case, but in some cases, they won't charge you. They just want you to use it in their space because they have more control over it. Patching software, for example. I never have to patch my budgeting software. It's just next time I log in, it's going to be running the latest and greatest version. So all of these things that we have to worry about, if we're running it ourselves, we don't have to worry about it with SaaS, but sometimes the companies don't don't give us a choice. But at the same time, I don't want to discredit what you said, because it is absolutely true that, we have to have more staff on support or on hand in order to support an IaaS or a PaaS environment. We have to better train our users in order to spin those things up and bring them to life and such. But, it's still a lot easier than managing the hardware as well. All right. So, any questions on IaaS, PaaS, or SaaS? Big Papa, that was a good question. So anything else you have, let me know, and we'll be sure to hit it up. All right. We do need to, again, this is all terminology I would expect that you need to know if you're going to go take the Encore. All right, next is something we call cloud deployment models. What are we on? Losing track. Cloud deployment models. Okay, this will look a little bit more familiar potentially, and it's a little more straightforward, sort of. Cloud deployment models, we have 4 of them that we need to talk about. We have private clouds, public clouds, hybrid clouds, and we have community clouds. Public cloud is what we've been talking about. Public cloud kind of boils down to that IaaS, PaaS, and SaaS conversation where I'm running it in somebody else's data center. Big Papa, PaaS is hard to nail down. Again, I really think one of the best examples is databasing. That way I don't have to install my own database on a server. I can just get a database application and tie that to, get a database and tie it to my application. But it's one of those, it's just less concrete. I think it's more of a case-by-case situation, whether it's classified as platform as a service or not. So either way, public cloud, we've covered those options. We know it's in somebody else's data center. Private cloud. I want to talk about private cloud because this is a little bit of a soapbox kind of moment for me. I don't know how to say it. It's something I care about. The concept of a private cloud, a lot of people say my private cloud equals my data center or equals my on-prem. And so I'll be talking to somebody and they say, yeah, I deploy that into my private cloud. Oh, what's your private cloud? Oh, it's my servers and storage in my data center. No. They are not the same thing, okay? Big Papa, all right. Dropbox and OneDrive, those are 100% software as a service. That's just logging in and accessing storage. I know it's only storage, but it's software. I mean, it's the exchange of that. That's my opinion. That's where you probably could make the argument it's platform because it's just storage. But for me, platform as a service is more of an enabling thing. And Dropbox is more of I'm going to store stuff there and pull it out. Like if I could tie my Dropbox to an application a little bit better, that might work. So like Amazon S3 storage is probably a little more platform as a service. Yeah, I'm talking myself into a corner here. I don't know. Do a Google search and see what people say. Yeah. If you can't tie it to another service, I'm going to say it's software. If you can tie it, because I don't even know for sure, like if I can take my Dropbox account and tie it into my Amazon servers and have them run off of it, I don't think you can. So I'm not exactly sure how Dropbox would classify as a as a platform as a service. That's a good one though. All right, so private cloud, not your dad's data center. I don't know where I was going with that, but it's not your data center. Your private cloud, if you're going to run a private cloud, you have to have those 5 characteristics. And we defined them earlier: on-demand self-service and measured service and broad network access and all of these things. We have to have those for the most part if it's going to be a private cloud. We don't have to have like all 5 of them 100% nailed, but you better see some of those characteristics if you're going to call it a private cloud. Private cloud, the advantage of a private cloud is, let's say I have that rapid on-demand self-service. This is my favorite one to bring up to people. On-demand, my pen stopped working there, sorry about that. On-demand self-service is a great example. I actually even said it earlier, I believe. If you have developers in your organization and they need to spin up virtual machines, how do they spin up those virtual machines? Now, this doesn't happen in every organization. I know a lot of organizations you say, well, I don't have developers who are spinning up virtual machines, and that's fine if that's where you find yourself. But in larger organizations or organizations that value developers, having programmers on staff working on various things, a lot of times they need to spin up new virtual machines and run tests and things like that. And so the question is this: how do they spin up those virtual machines? Because if the developers have to call you up and they have to be entered into a queue, even if it's submitting a ticket, same thing, right? I don't care if it's physically calling you or not. It could be submitting a ticket. If I have to sit there and wait for an IT person to get around to it and maybe even wait until the next day, it's not on-demand self-service and it's not a private cloud. Meanwhile, our developers see that I can go, yeah, I can call my IT shop and it's going to take a long time. Guess what else I can do? I can go up to the public cloud and I can start working today. I mean, y'all, I've been there where there was a situation at work that one of our security guys had installed a firewall between our lab environment and our production environment. And our lab environment was largely out of band anyways. Like, there was no way anything could get across that. He just, there was just going to be a firewall there. And I was fine with that. Like, that's fine. It doesn't particularly affect me, and at least it didn't until it did. And there was a day where I had, under the gun, I had to log in. I had to validate configuration for a customer. And that doggone firewall was blocking my connections and my security guy wasn't available. You can bet I went down there and completely bypassed that firewall to get my job done. Okay, that's called shadow IT. And shadow IT, it was a popular phrase about 6 or 7 years ago. It's fallen a little bit out of vogue these days. But the idea is I'm going to do what it takes to do my job. These developers are being assessed just like we are at our jobs. They have criteria for success. One of these developers might need to spin something up on really short notice. And so what they're going to do is, I guarantee you, they're going to go spend the money via their company credit card or their manager's approval or what have you. They're going to go spend dollars to spin up that virtual machine when they need it. And this is one reason why IT was becoming irrelevant, especially 5 years ago. And IT had to really step up their game because, in a weird way, we in IT are competing with Amazon. We're competing with Microsoft and Google because they're going after our customers, which are our own IT staff or our own non-IT staff. So this is where we need to be business enablers and be thinking along those lines. We're going to find ourselves without a job, whether we're outsourced or they just more or less say, well, we're moving so much to the cloud, we don't need as much staff these days. That's certainly the biggest threat. So if we can spin up software, and Cisco, by the way, makes this software. They have a platform called UCS Director. UCS Director is a self-service software package that developers now can go here to UCS Director instead of going to the cloud. That way they can still click, 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 spin up their own virtual machines, and we're done. So this is part of matching these 5 characteristics. UCS Director allows for rapid elasticity. It allows for measured service. It allows for all of these NIST characteristics that they say is part of every single cloud deployment. So this is where, again, I would argue and maintain an on-premise data center is not a private cloud unless it is meeting those 5 characteristics as much as possible. Dropbox does have public APIs you can use to share your data with other apps. There we go. All right. Well, then I would consider that platform as a service, although I would argue that you can consume it either way then. And that's why it's not black and white and concrete and all that. It can be a little bit of all over the place. All right. We'll come back to hybrid cloud here in a moment, but community cloud. So this community cloud concept is interesting. You and I are probably not going to see much of this, depending on, if you work for a university or a healthcare system, you might every now and again. I think those are the 2 biggest examples. It really comes down to, in some way, we're sharing a set of data center resources with another organization. So it's not a public cloud, it's not my private cloud, but it's a shared resource with collaborative organizations. So again, universities, this can be popular in universities. If you've got 5 universities all part of one research project, maybe one of them opens up part of their data center to be called the home of this community cloud, and everybody has equal access to it and can, spin up resources and spin down resources and such. So another one might be healthcare organizations. You might have, and those are usually, I'm still thinking of like research, so it's tied to universities. But, if you have a healthcare research organization that's collaborative and working with other ones, then, then maybe they'd spin up a community cloud. It's one of these, like, you have to know that it's one of them. It's 4 of them. I've never personally engaged with a community cloud. I've never even seen one. Trust me, it's not to say they don't exist. They absolutely exist. But you have to be part of the right communities. I don't know. You have to be part of the right organization in order to see community clouds. Okay. Last but not least, let's talk about the hybrid cloud real quick. So the hybrid cloud concept is this. Hybrid cloud says that I've got ideally an actual private cloud. Hopefully now you know what that is. And a public cloud. In fact, I could really have multiple clouds. I could have multiple public clouds. I could have just multiple public clouds, period. I don't even have to have a private cloud. But the idea is I have many different options available to me. So maybe this one is Amazon. Maybe this one is Microsoft Azure. Maybe this one is Google Cloud GCP platform, right? Google Cloud Platform, GCP. And a hybrid cloud says that I'm going to, in some fashion, distribute my workloads among these different clouds. Now, from a technical perspective, a hybrid cloud usually does involve your private cloud, so I probably should rescind what I said before. That said, Cisco likes to use the word multi-cloud, and multi-cloud could exist without a private cloud. You could just truly have 3 different cloud deployments. And so usually what are you going to have is you're going to have a set of software, like an Arbiter, I remember. A cloud brokering software. That's usually what we call this. So a cloud broker, I'll just call it cloud broker. A cloud broker set of software is going to allow me as the user to say, hey, I wanted to deploy this application, and the cloud broker is going to say, all right, here's your options. You can deploy it into the private. You can deploy it into Amazon, and you can deploy it into Azure. And here are the costs for deploying into each one. Here is the time. Here's the, how long it would take to spin it up and everything. And I get to choose where to deploy my workload. And so in some cases, it's happens to be cheaper to deploy in Azure that day. So I'm going to deploy it into Azure. We think of them all as being the same, but Amazon, as you go up the scale of server sizes, you might have, Amazon's in this column and Azure's in this column. They might have, Amazon might have their 4 different sizes, for example. They have a lot more than 4. But here, in these 4 sizes, and Azure might be something like this, where they've got, they're staggered, and so if I need exactly that many resources, Amazon would be a better fit. But if I need exactly that many resources, Azure might be the better fit, because Amazon, I'd have to go up higher in order to get the amount of resources I need. So depending on the application, I might spin this up in Amazon or Azure, or yes, my private cloud, because now I have UCS Director, and that's an option for you just to spin it up in UCS Director, and this cloud broker software would integrate with UCS Director just like it integrates with Amazon and Azure. Cisco, by the way, go figure, has a cloud brokering software. It's called Cisco Cloud Center. And Cisco Cloud Center was an acquisition they made called Clicker, CLIQR. And a lot of people still refer to it as Clicker, which is why I bring it up. So Clicker is Cisco Cloud Center. Technically speaking, we don't say Clicker anymore. We're not supposed to. But either way, it's this cloud brokering software that allows us to deploy a hybrid cloud. A hybrid cloud is truly designed to be a best of both worlds approach. I've got all of the services and availability of the public cloud. I've got the cost savings potentially of my private cloud, and I can choose the best cloud for the need. And, something to keep in mind too is we talked about at the start about data and how secure that data for some organizations needs to be. If you're a hospital and you've got patient information, that's got to be super secure. And there might even be laws that say you can't store that information in a public cloud. versus, I don't know, just inventory data. Inventory data, who cares? It's temporary. It's not going to last, very long. It's not going to be relevant very long. And it's not super insecure. Nobody's going to, you can't sell that information on the dark web or what have you. So yeah. So it depends on the application, depends on the data. But there might be some applications that we say, you know what? If it's tied to this system, it has to go into our private cloud. But hey, if not, then spin it up wherever you want. And there might be an application that we want to take advantage of serverless computing in AWS. Well, I can't do serverless computing in my private cloud, so go ahead, spin that up in Amazon. This is that best of all worlds approach, really. All right, Ben. Sounds like OpenJS Foundation uses a community cloud model. Yeah, okay. They run Node.js, Electron, many other big OSS projects. Yeah, you're going to find a lot of those kinds of things. Open source is an interesting one because you're right. As they share data, usually they're going to do that in some kind of community cloud. I almost wonder if like GitHub and GitLab, if those would count as community clouds, because we store a lot of data up there. I mean, I've got coding projects in GitLab, for example. It's a public cloud, but it's also something that like everybody can have access to. So like I could see it being categorized as a community cloud, but this is where, again, it's just not as black and white as we'd all like it to be. All right. Believe it or not, that is that is the end of this session. We ended a little early tonight, but if you have any questions, please, I've got a few minutes here, so anything on this or anything else Cisco related, we can chat about. Cisco makes their money in the actual data center. We mentioned it earlier. They have Cisco Nexus, Cisco UCS, and MDS switches and such. But they also have a ton of software. And this Cloud Center software is one example. They've got UCS Director is another one. And they've got a myriad of others. AppDynamics, Tetration. Tetration's kind of a hardware or software thing. But either way, I mean, they can make their money anywhere. So Cisco wants to be a cloud agnostic shop. They love the idea that they can help you decide which cloud to go to. They don't want to have their own cloud. At least that's been their direction. They always had a direction, and then maybe in a month they're going to announce, hey, we've got a public cloud offering. But Cisco does offer software as a service. WebEx is a great example of that. WebEx Teams. There are quite a few. In fact, Tetration they now have. Tetration is a huge analytics engine for your data center. So that is now available as a software as a service option. So they're getting more and more vested into some of those options for their software as well, so you don't have to go install it on-prem. The public cloud is a great resource, but I usually caution people away from thinking that that's the only solution. The best time for you to be locked into a public cloud is if you're a startup. You're either really, really small, because if you're really, really small and you're a startup with like 5 dudes, or I don't mean that and guys or girls either way, but you got 5. I'm just thinking of like, I don't know, a bunch of people, college graduates eating pizza for some reason. But either way, you've got 5 individuals who have started this company, and they're not going to go out and buy a bunch of servers and start installing applications. They're going to go out and use the cloud resources as much as possible. That's the reality. But eventually, as they consume more, I mean, the cloud ain't cheap. And eventually you're spending, I worked with one company, they were spending, I want to say it was $18,000 a month to run their infrastructure in Microsoft Azure. And we ran the numbers, and we were going to be able to position a good Cisco hardware, UCS, Nexus, VMware software or hypervisor. We're going to be able to, all of it, I think, for like $80,000. So that's like a 4-month return on investment for what they were spending in the cloud. And not every cloud deployment is that drastic, but every now and again you catch that where it's like you're just running something hot, and because you're running hot, remember that application I mentioned with the prom, right? Where they every once a year they're spiking up. If you're running that hot all year round, you should just buy that and put it in your data center, because you're going to be paying a lot of money to be running that all the time. However, there are some organizations that are so large, like again, we mentioned Netflix, that it's just, they would rather not. I mean, that's heavy for them to, I shouldn't even say it like that. Netflix could absolutely run all their own data centers if they wanted to. The problem for Netflix is they vary so much from region to region that, again, any place around the world, you're going to have a busy time in the afternoon and a busy time in the early to late evening, and then you're going to be basically dead overnight and through the working day. So for them to try to manage that themselves, they view Amazon as a great solution for that. And it's worth the cost for them as much as anything, because they're flush with cash. When you have half the world subscribed to you, I suppose. Dudes can be any gender. Actually, I've made that argument as well. It culturally, dude means guy, dude means man, but when you look at the history of the word, it can. I'm sorry. I'm thinking of guys. Did you know the word guy can actually mean man or woman? Guy is actually genderless. Dude, I would argue dude is a man, but dudette, isn't it dudette? Or is that maybe that's just a California 80s thing? I don't know. Teenage Mutant Ninja Turtles just jumped into my mind. So either way. So yeah, Netflix chooses to use it. So you have to have a use case. Okay. The thing I always caution people on is, don't just go to the cloud because it's the cloud. I think that's the danger, is a lot of places are like, well, it's cloud time. Everybody's moving to the cloud, and I don't like running on this expensive hardware, because it is expensive. It's like, I've got a quote from you, Jeff, for $100,000 worth of Cisco equipment for my data center. And so they run out to the cloud because here's a great example, right? You run a test. You're like, okay, I've got 100 virtual machines. I'm going to move 10 of them up to the cloud. And so, it's costing me $1,000 a month. That's a tenth of my environment, 10 of my 100 virtual machines, basic math, right? $1,000 times 10 is $10,000 a month. So it's going to cost me $10,000 a month. Maybe I'm actually quoting $250,000, right? It's like $10,000 a month. I'd really rather spend that. I know that's a 2-year return on investment. That's a lot harder to justify. So I'm just going to go to the cloud. Well, they spend all of this time and effort moving to the cloud, and what they find is that those 10 virtual machines that they moved, what do you think? You think they're the you think that those were the hardest hitting VMs? No, it was a test. They moved a domain controller up there, and they moved a small storage server or something, a file server. Whatever they moved up there wasn't using up 10% of the utilization. It was using up like 2%. And so they move all this stuff up there, and all of a sudden their bill comes in, and it's $20,000, $25,000 a month. Like, whoa, what happened here? And now my $250,000, even though it sounded super expensive, you're going to spend $300,000 a year trying to keep this cloud deployment online. So that's kind of a tale as old as time. Cloud has its purpose. It's not to be everything. It's to be used for the value that it provides. If you need on-demand self-service, you're not getting that out of your private data center. I would argue it's not a private data center anymore, but either way, if you're not getting it out of your on-prem deployment, great. That's a good example. Use that. You need, again, serverless. Use Amazon. You need federated domains, right? That's what a big part of what Microsoft provides. Use Azure. Like, they've got these great solutions. We don't need to just say, all right, that means we're going to move all of our virtual machines up there. Should never be our approach. All right. Well, everyone, thank you very much. Again, just one quick last time on this. Starting in a few weeks, I'm going to be showing up on YouTube Live as my platform of choice. So hopefully that works for everybody to meet up over there instead. I will miss some of the benefits of Twitch, the whole reason I went with Twitch, but I do think that it's going to be better from just a content archival perspective over on YouTube as well. So definitely advantages and disadvantages to every platform, but as much as anything, my organization that by and large sponsors this is looking to make that move. So I'm happy to go along with that. So there's some great people over there: Keith Barker, Jeremy Chara, Chuck Keith. I'll be in good company. not gonna lie. So thanks for everybody who has participated in this, especially some of you from the beginning. It's been a lot of fun. I've been on Twitch now for about 3 months. I think maybe even 4 months. I think it was December. And trust me, I'm not going anywhere. We're going to keep cranking on content over at CBT Nuggets. I'm recording Encore Nuggets every single day. We're going to get that content out as fast as possible. And I'm going to keep doing these live streams as long as they're valuable to people. So as always, hit me up on Twitter. Let me know what is valuable to you, what you'd like to see out of these live streams. And yeah, don't hesitate to just reach out for anything. LinkedIn, Twitter, YouTube. I'm all over the place. So yeah, December. Yeah, it has been a while, that's for sure. It's been a lot of fun. All right. Well, with that, everyone, have a great rest of your night, and we'll see you when I come back.